Lesson 1. Functions and Relations. Function. A function is a relationship between two sets, such that each value of the first set is associated with exactly one value of the second set. Example, the first set contains 1, 2, 3, 4, while the second set contains of 2, 4, 6, 8. The first set is represented by the variable x, while the second set is represented by the variable y. So therefore, instead of writing first set, we will use x. Instead of writing second set, we will use y. Again, if x is 1, y is 2. If x is 2, y is 4, x is 3, y is 6, x is 4, y is 8. The first set of independent variables is the domain, while the second set of dependent variables is the range. For each element of the domain, there corresponds exactly one member of the range. So y is known to be as the dependent variable because it depends upon the value of x. Therefore, for each value of x, there corresponds exactly one value of y. X is 1, y is 2, x is 2, y is 4, x is 3, y is 6, x is 4, and y is 8. Review. Blank is a relationship between two sets, such that each value of the first set is associated with exactly one value of the second set. Answer. Function. Number 2. Blank is the set of independent variable. Answer. Domain. Number 3. Blank is the set of the dependent variable. Answer. Range. A function is used to describe how one variable depends on another. Example, x is known to be as the input and the function is the process, and y will be the output. In order for us to get the value of y, we need to have the value of x. So again, x is our dependent variable, or x is our independent variable, and y is our dependent variable. For example, the amount of money a worker makes is a function of how many hours he works. So the number of work hours is the dependent variable that pertains to the value of x, while the amount of money earned depend on the number of work hours that a worker works. So it is a dependent variable which is labeled by the variable y. And the function pertains to the rate of the worker per hour. The number of hours the worker spends on his job is called the independent variable, while the amount of money he makes is called the dependent variable. Example, a worker is paid or will be paid 80 pesos per hour. Our dependent variable or the value of x is 8 hours. So find for the value of y. We will enter our input, which is 8 hours, to our function machine. When we're in, every hour of works will be multiplied to 80. So that will be 80 times 8 equals 640. So the earning of 640 depend on the number of work hours that the worker works. To convert that in a mathematical sentence, x is equals to 8 and f of x or the function of x is equals to 80x. Substitute 8 to the variable x. So that will be function of 8 or f of 8 is equals to 80 times 8 equals 640. Let's try this. Okay, so if x is equals to 8, y is equals to 640. While for the second one, if the worker works for 12 hours, so how much will be his earnings? So the function states that f of x is equals to 80x. If x is equals to 12, f of 12 is equals to 80 times 12. And 80 times 12 is equals to 960. So if x is equals to 12, f of 12 will be equals to 80 times 12, y will be equals to 960. While if x is equals to 4, what will be the value of y? So let's go back to our function. Function of x is equals to 80x. Supposed to be the worker works for only half day, for only 4 hours. So that will be the f of 4. So 80 times 4. And that will be equals to 320. So therefore, if the worker will work for 4 hours, he will earn 320 pesos. If the worker will work for 6 hours, so that will be 80 times 6, that will be equals to 480. Then if the worker will work for 10 hours, that will be f of 10 equals 80 times 10. So the function of 10 is equals to 800. Relation. A relation between two sets is a collection of ordered pairs containing one object for each set. A function is a type of relation. So example, we have the relationship between two sets. X is equals to 1, 2, 3, 4, while Y is equal to 2, 4, 6, 8. All functions are relation, but not all relations are function. Example, the domain contains 1, 3, 5, and 7, while the range contains 2, 4, 6, and 8. So this relation is considered to be a function. Let's go first to the third example. The domain contains -2, 2, 3, and 4, while the range contains 4, 4, 9, and 16. As we can see, so we have the same value of the range for x which is equals to -2 and 2, and x equals to 2. And that is considered to be a function also. So let's take this into consideration. F of x is equals to x squared. Okay, so let's consider -2. F of -2 is equals to -2 to the second power, and that will be equals to 4. Okay, check. While, let's consider the second one, 2. F of 2 is equals to 2 to the second power, and that will be equals to 4. Check. Which only means that there's a possibility that we will have different value for x, but we have the same value for y. And still, that is considered to be a function. Then, for the second example, it is very impossible that the value of x is the same while the value of y varied. Example, if f of x is equals to x plus 1, so that will be f of 2 is equals to 2 plus 1 equals 3. So it is very impossible that if we have one value of x, the value of y will be varied. So if x is 2, there's only one or exact one value for y, which is 3. Relation as a function. Varied x, varied y, that is a function. Varied x, similar y, is also a function. Similar x, varied y, so that is not a function. Review. Determine whether the following relation is a function or not a function. 1. X is equals to 2 to 1, 2, 3, 4. Y is equals to 4, 8, 12, 16. Function. 2. X is equals to 2, 2, 3, 4. Y is equals to 5, 6, 7, 8. As we can see, we have a similar value for x that gives different value for y. So that is not a function. 3. X is equals to 1, 2, 3, 4. Y is equals to 5, 4, 7, 4. So we have varied value for x, which is 2 and 4, that give same value for y or similar value for y, which is 4 and 4. And that is a function. 4. X is equals to 0, 12, negative 4. Y is equals to 4, 8, negative 5. Function. 5. X is equals to 2, negative 2, negative 2. Y is equals to 4, negative 4, negative 6. As we can see again, we have similar value for x that gives different value for y. Not a function. Function can be represented by a set of ordered pairs. So we can convert this table as a set of ordered pairs that is enclosed in a pair of bracket. First ordered pair, we have 1 and 4. Second ordered pair, we have 2 and 8. Third, 3 and 12. Fourth, 4 and 16. Review. Represent the following functions as set of ordered pairs. 1. So we have 1 and 5, 2 and 4, 3 and 7, 4 and 4. 2. We have 0 and 4, 12 and 8, negative 4, negative 5. 3. We have 2 and 4, 4 and 8, negative 4, negative 8. Function can also be represented by a graph. A graph of ordered pairs can be considered to be a function by using the vertical line test. The vertical line test determines whether a relation is a function or not by passing or drawing a vertical line through the graph of its ordered pairs. A relation is a function if the vertical line intersects or passes the graph through one point or through the graph in only one point. Conversely, a relation is not a function if the vertical line intersects or passes through its graph into two or more points. Example, the following graphs are examples of function. We have here our x-axis and we have the y-axis. And the graph of our function is this curve. If we will draw a vertical line anywhere along the graph, it will only passes the graph through one point. So therefore, this graph is a function. 2. We have here the x-axis and the y-axis. And this is the graph of our function. If a vertical line again is passes through the graph or anywhere in the graph, it will only intersect the graph at one point. So therefore, graph number 2 is a function. 3. We have here the x-axis and the y-axis. So this is the graph of our function. If we will draw again a vertical line anywhere in the graph, it will only intersect the graph at one point. So graph number 3 is also a function. 4. This is the graph of our function. And if you passes again a vertical line anywhere in the graph, it will only intersect the graph at one point. So graph number 4 is a function. The following graphs are not function. So this is the graph of our relation. And if you passes a line in our graph, it will intersect the graph at 2 points. So therefore, it failed the vertical line test. So this graph is not a function. 2. This is the graph of our function. Then our vertical line intersect the graph at 1, 2, 3, 4. So it intersects the graph at 4 points. So graph number 2 is not a function. 3. Our vertical line intersects the graph at 2 points. Graph number 3 is not a function. 4. Our vertical line touches the graph at 1, 2, 3, 4 at 4 points. So graph number 4 is not a function. A function can also be represented by a graph. Instruction: graph the given coordinates, then determine if the resulting graph represents a function or not. Example: the value of x are 1, 2, and 3, while the value of y contains 1, 4, and 9. So if we will apply the vertical line test in this function, so we'll have here our x-axis and our y-axis. First point, we have 1 and 1. So we have positive 1 and positive 1. So this will be our first point. Second, we have 2 and 4. So positive 2 and then 2, 3, 4. And then 4 for the y-axis. So we'll have our graph here. Third, we have 3 and 9. So we have here 3, and let's assume that 9 is somewhere here. So this will be our third point. So if we passes a vertical line along these points, let's connect first the points of our graph. So if we will pass a vertical line along these points, it will only touches the graph at one intersection. So therefore, the given function or the given ordered pairs is considered to be a function. Example number 2. So we have negative 4 and negative 4 for the first ordered pair, 0 and 4, 2 and 8. So let's have our Cartesian coordinate plane. Negative 4, negative 4. Okay, so we have the first point here, 0 and 4. We will have our second point here, 2 and 8. And example, we have our 8 here. So 2 and 8. Then connect the points. So again, if we will pass a vertical line anywhere in the graph, it will only touches the graph at one point. So the given set of ordered pairs is a function. Example number 3. Let's have again our Cartesian coordinate plane. First point, negative 4, negative 8. Second point, negative 1, negative 2. Third point, 3 and 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, let's connect again the points. So if we will pass again a vertical line anywhere in the graph, it will only touches the graph at one point. So the given set of ordered pairs is considered to be a function. Function represented by an equation or formula. To show that the equation represents a function, we need to demonstrate that for all possible values of x, there corresponds a unique value of y, or f of x. So f of x is equals to y. So therefore, this y is also equals to f of x. Example number 1. We have here f of x is equals to 3x squared. Let's solve for the value of y if x is negative 4. So we will have here the function of negative 4. So that will be equals to 3 times negative 4 to the second power. And that will be equals to 3 times 16. And 3 times 16 is equals to 48. So we have here 48. Next, function of negative 2. So we have f of negative 2 is equals to 3 times negative 2 to the second power. That is equals to 3 times 4. And that is equals to 12. So if x is negative 2, y is 12. Next, we have x is equals to 0. So f of 0 is equals to 3 times 0 to the second power, and that is equals to 0. So if x is 0, y is also 0. Next, x is equals to 1. So f of 1 is equals to 3 times 1 to the second power. And that is equals to 3. 3. X is equals to 3. So we have f of 3 is equals to 3 times 3 to the second power. And that is equals to 3 times 9. 3 times 9 is equals to 27. If x is equals to 3, y is 27. So if x is negative 4, y is 48. If x is negative 2, y is 12. If x is 0, y is 0. If x is 1, y is 3. If x is 3, y is 27. Example number 2. F of x is equals to square root of x. So the first value of x is 1. F of 1 is equals to square root of 1. And that is equals to 1. So the square root of 1 is 1. Next value, x is equals to 4. F of 4 is equals to square root of 4. And that is equals to 2. If x is 4, y is 2. Next, 9. F of 9 is equals to square root of 9. Square root of 9 is equals to 3. If x is 9, y is 3. Next value, 16. So f of 16 is equals to square root of 16. And square root of 16 is equals to 4. And last, we have x equals 36. F of 36 is equal to square root of 36. And square root of 36 is equals to 6. So if x is 36, y is 6.